Okay, so today we're going to start talking about congruent figures. This entire chapter is about proving triangles congruent. So we just start off with some basics here. So up at the top of your notes, if you just underline congruent figures, and what we have to figure out here is when we have congruent figures, they have congruent corresponding parts. So that means that they have, in the shapes that I have over here, A and E are equal to each other, which means that the angles are equal to each other. Angle B is equal to angle F, and then also the segment AB is going to be equal to segment EF. What we need to understand when we're naming congruent figures is that the order matters. If I look over here at my congruency statement, I will notice that angle A and angle E are equal to each other, just like we said. Angle B is equal to angle F, and so on. Angle AB is equal to EF. So like the letters matter. The first letters are going to be equal to each other. The second two letters will be equal to each other, and so on. Same thing will go with the segments. The order that we put them in matters. So over here, if the triangles to the right here are congruent, we're going to name them and write a congruency statement. And so if we can see here, triangle ABC and triangle this triangle right here, they're equal to each other. They're a reflection. They're reflected over that line BC. And so when I name them, I want to be able to name them with corresponding parts. So if I label the one triangle, triangle ABC, I want to make sure that, again, if they're a reflection, that angle A is going to flip over to angle D. Angle B is going to stay put and be equal to angle B, and angle C is equal to angle C. So each of those segments should be corresponding, and all the angles should be corresponding. Again, with equal triangles, I can solve and I can find the measure of all the angles. So solving for x, I would know that since this angle right here is 90 degrees, that this angle as well would be 90 degrees. So I can say that 2x minus 16 is equal to 90. So 2x is equal to 106, and x is equal to 53. Whoopsie. On the other side, so what's the measure of angle DBC? So what I can do again is DBC is this angle up at the top here. So I know I've got a 90-degree angle. This angle right there will be 49.3. And so I can just do 180 minus 90 minus 49.3 to get that this angle right here, angle DBC, is going to be equal to 40.7 degrees. So the biggest thing that we're doing kind of this chapter is making sure that from our written given statements and from our picture, we can figure out what is equal in two triangles we're trying to prove equal. So when I see right here that B is the midpoint of AC, I know that B is the point B right here is going to cut AC in half, and so I know that AB is going to be equal to BC, and the reason that I'll put down would be definition of a midpoint. So again, midpoint means it cuts it in half, which means it breaks it up into two equal segments. The second one, BD bisects angle ADC. The one thing we need to make sure is when an angle is being bisected, we need to know that angles will be equal to each other. So an angle is bisected, that means that two angles will be equal to each other. And so again, bisect means that it's being cut in half, so angles are equal to angle. So when I look at my picture, I can look up here at angle ADC and know that that's being cut in half by this line BD. And so I would know that these two angles are equal to each other. So with that, I can say that angle ADB is equal to angle CDB. and I would say definition of, and I've got to say angle bisector. Angle bisector cuts an angle in half and breaks it into two equal angles. This next one is one that's kind of different. So again, it says that BD is shared between both triangles. So if we look at triangle ADB here and triangle CDB, the overlap is BD. And so what I can say is that BD is equal to BD by the reflexive property. Oops. So again, reflexive property means stuff is equal to itself, and so we'll use it when we have an overlap between side lengths in two triangles. And then the last one that we have here, BD is going to bisect AC, so AC is being cut in half. And since AC is a segment, it's going to mean that segments are equal to another segment. And so if I look here, I've got DB is cutting this segment AC in half, and so I know that AB will be equal to BC. AB is equal to BC. By definition of, and again I got to specify, a segment bisector. So when we're doing proofs in this chapter, these will all have to do with proving triangles equal. This is kind of the steps that we'll go through. So the very first thing that we want to do is we want to write as much as you can by looking at your written given statements. So that is just where it says given and then tells us a bunch of information. We want to look at our written given statements first. The second thing we want to do is we want to look at our picture. In our picture, we can use vertical angles and we can use reflexive property. Again, reflexive property is as a segment or a side length that is the same exact side length in both of our triangles, and vertical angles is when my picture looks like a bow tie or an hourglass. And then the last thing is, as we do this, we want to mark on our picture what is equal to what. So we want to actually draw it on our picture because that'll help us as we're trying to prove triangles are equal. So here with this problem, again, very first thing I'm going to do is I'm going to go ahead and, my first step would be writing down my given statement. So angle YWX and angle YWZ are right angles. I'm not going to write all these out. First step is my given statement. There we go. That sounds good. My second step, so again, what I'm going to do is I'm going to go through and with each of my written given statements, I'm going to write what I know. So right here it says that angles YWX and YWZ are both right angles. So if they're both right angles, I know that they're both equal to each other. So again, since we say that they're right angles, I know that those are going to be equal to each other. So I know that angle YWX is equal to angle YWZ. And this is by, whatever you want to say it, 90 degree or right angles equal 90 degrees. I'm going to say definition of right angles. And really the technically correct way of doing it is to say that both those angles are equal to 90, and then use the substitution step to say that they're equal to each other. But we can do this. We can do this kind of shortcut. The next thing, again, I want to say that. So my written given statement says that YW bisects angle XYZ. And so again, if the angle that's being bisected is XYZ, I know that these two angles up at the top are going to be equal to each other. So I can say that angle XYW is equal to angle ZYW. And again, since it's an angle bisector, I can say definition of an angle bisector. So I almost forgot to mark that these two angles are both equal to each other because they're 90. And then the last one that I have is that W is the midpoint of XZ. So if W is the midpoint of XZ, that means that XW is equal to WZ by definition of a midpoint. Again, I can mark it on my picture. This segment right here is equal to this segment right here. And then in my given, I have XY is equal to YZ. So on my picture I can mark XY and YZ equal to each other. Again, single marks are congruent with single marks, double marks are equal with double marks. So again, after I'm done with looking at my written given statements, I can look at my picture. What I have in my picture is, if you can see that, WY is a part of both of the triangles. And so I can say with my fifth step that WY is equal to WY. And I can say that by the reflexive property. And that's all that I can say from my picture. From that information, I should have enough to say that the triangles are equal to each other. With the example down at the bottom, again, same thing. First step, my given. Second thing, look at my written given statement. So AD bisects BE. Again, a segment is being bisected, so BE is being cut in half. And so if BE is the one that's being cut in half, I know that BC is equal to CE. So BC is equal to CE by definition of a segment bisector. I can look at my next given statement. It's just AB is equal to DE. So AB is equal to DE, 2 lines with it. Then I can go ahead and look at my picture. If you notice, the picture looks like a bow tie. Bow ties and hourglasses, I'm going to have vertical angles. And so with this one, I've got a big X, and so these are going to be my vertical angles, these 2 angles. So that's angle BCA is equal to angle DCE by vertical angle theorem. So again, just like as we go through this, we're gonna get better, and we're gonna get more technical with it. But first we're gonna look at our written given statements, write as much as we know from our written given statements, and then we're gonna look at our picture to get any more information that we have. We're going to mark on our picture so that at the end we can say our triangles are equal by some sort of theorem.